I'm Dr. John Young with Foundational Health Center, a medical doctor here in St. Petersburg, Florida.
Hi, I'm Alex. I'm a nurse practitioner and we work together.
Yes, we do. You know, our practice has kind of gotten the reputation as if the other doctors don't get them better, they send them to us.
Oh, yes. Yeah.
So we really, it's nice to get a few easy colds or sore throats, and that's pretty easy. But most of our cases are very tough cases, and they've had issues for years and years and years. And the question is, so John, what are you and Alex going to do to get me better? I've seen everybody. I've been to, the universities. I've seen them. I've seen this Mayo Clinic. What are you going to do? And we're just going to share with you from cases that we've seen, most of them very recently, about how you get a patient better, or one of the tools you can do when basically the labs don't help you, the different treatments don't make any difference. What do you do when you run out of options? We've got some options for you. So Alex, take it away.
Yeah, so a lot of times, you're so right, we get these patients sometimes out of state. They come here just to see you because they've been everywhere, they've done all the tests. And what we notice is that the tests don't match what they're telling us. So everything's normal, So what's the next step? One of the things that we like to use a lot is the genetic test, but in a different way. We like to make the genetic test useful for our patients. It's not the genetic test in the sense of doing, let's say an example, the BRCA gene and see if you have a predisposition to develop breast cancer or not. The way we look at it, we're looking at right now, we look at your genetic pathway. So it's really what I like to call functional genetics. So we actually look at all genetic pathways as far as your methylation, as far as your liver detoxification pathways. And what applies to you, how can we help you to bypass certain genetic mutations that you have that it's causing some of your symptoms. So we do have some clinical examples. That's how, because one thing is what's in the literature that we can actually look in research, theoretical thinking, but we have been able to apply that in clinical practice. Some cases are very interesting. So do you want to talk about one of your cases?
Well, I'll talk the one that I recently, it was just a couple weeks ago. I had a lady about 60 years old come in to me, very concerned because she's losing her vision. Then I got very concerned too, and it was happening over several weeks. And she had been to see the university eye specialist here. I went somewhere else out of town to see a very well-known eye clinic, and saw everybody, and they just said, we really don't know what's happening. She was very worried because at night she has no vision. Her husband has to lead her around the house. The colors are just kind of drab. They're just blah. Things are turning gray. And it's happening not over years, but it's happening over weeks, getting worse and worse and worse. The only thing she did say is one doctor said she had a very low vitamin A, but they didn't, giving her vitamin A didn't seem to make any difference. So they had nothing to tell her. So she came to us, and we looked at her laboratory data, and sure enough, it all looks great. It always is fine. So we break people down biochemistry, physiology-wise, but she hadn't already done that, so we then will go to the next step, which is the genetics. And so I had suggested she get a test called the 23andMe. And yes, that test tells you you're 20% Irish, 30% Swedish, whatever. But the other part of that test tells us a lot of your genetic code, all the genes that make you up, and it's just pages of genetic material. And so she had it with her. And so she gave it to us. And I started to go through it, and Alex and I, we talked about it. And a couple things really jumped out. One is she had an MTHFR defect, so she didn't methylate well. The other thing is she had a BCMO1 defect. And you say, well, are you just making up these letters of the alphabet? No. That gene codes for the ability to get carotene, beta carotene, across the cell membrane into the cell, vitamin A.
Yeah.
The other thing is she had a VDR-TAQ serious genetic defect and a GC genetic defect. And you're saying, okay, so what does that mean? Well, a couple things. With VDR and the GC defect, she really had very little vitamin D in her body, and it's very hard for her to absorb vitamin D. And vitamin D is an oil-soluble vitamin.
Yeah.
Really, it's a hormone.
Right.
The other thing is vitamin A is oil-soluble, none of one of those vitamins. And she had a genetic defect that really, she cannot absorb any vitamin A. So we started thinking, and we said, you know, what if she has these genetic defects? What if the problem is she can't get it across the cell membrane into the cell?
Right.
So I'm famous for this young shake with the protein and oil combination. And we know that to absorb an oil, it's best absorbed when you hide it or emulsify it in a protein. So I had her take our protein, mix a large amount of vitamin A, a large amount of vitamin D, oil-soluble vitamins, and she made an emulsion of this every morning and had it every morning as her breakfast. She came back 4 weeks later, a very different woman than when I first met her. She was really depressed, really drab, really blah. I'm going to be blind by December. Here it is, October. And John, the colors are so vivid, they're so bright. And no more night blindness. My husband doesn't have to lead me around the bedroom. You know, every once in a while I'd see my bed and it looked like a pile of leaves. I can see my bed. Everything looks great. And that's where no one could figure this out. And that's where we have the ability, just because we study a lot, we have a very boring life.
Right.
And we broke her down genetically. Yeah. And just because you have these genes malfunctioning, doesn't mean you can't find a secondary pathway to do
something about it. And you really have to understand, like you said, what these genetic mutations do. And once you understand the chemistry, the biochemistry, then you can bypass. Then you can use other tools to make that work for you. It doesn't mean that you have a genetic defect that, oh my gosh, it's the end for me. And no, there's always usually something that we can do about it. One of the things that I use a lot, the genetic test, there's a COMT genetic mutation. And that genetic mutation can give you, if you have a double, what we call homozygous mutation, can give you a lot of anxiety. And especially for my ladies, female ladies, what happens is if they have high estrogen, it's usually because there's a genetic mutation on the COMT pathway, and your estrogen levels are going to be very high, and your ability to detoxify estrogen, it's going to be diminished. So if I understand that, if I know that you do have that genetic mutation, there are certain things that I can do for you to help your enzyme, your genetic mutation, to work in your favor, not against you. Because usually those genetic mutations, they're not meant to hurt you. They are just meant to adapt your body for optimal performance. But because we have changed so much over the years and the millennia, we have a more urban lifestyle, so things are different. We're no longer chasing after animals to try to feed ourselves. So all these genetic mutations, they can go against you in the current environment. So the COMT, it's also very interesting because if I have a patient with the MTHFR mutation, which is a different mutation that also can lead to anxiety, then I have COMT and MTHFR. That's going to be a patient with a lot of anxiety and a lot of hormone, genetic estrogen problems. So I have to actually treat both. You see, that's where we come in. We don't look at one genetic mutation in isolation. Usually we look at a cluster of genetic mutations. So then I'll treat the MTHFR as well as the COMT. Another interesting mutation that I think, especially for women, is the DAO. There's an enzyme that breaks down histamine. And usually that enzyme goes low function during your period or a little bit before your period. So during or before your period, that's usually during the time that I have my ladies come in with either an itch or a rash, something in the skin going on, or they're like, I don't know, I can't drink wine, I have this anxiety, and then I have this itch. What happens is it's during their period, because the estrogen levels change, their DAO enzyme goes low and they cannot break down histamine. So there are things we can do to help them to break it down during that time. But it could be always. I actually had a patient with this one case. I think it was interesting because her situation wasn't an itch or anything, was her bladder was super irritated. For anything, she would eat all kinds of things and the bladder would be super irritated. We found out that she has a genetic mutation in the breakdown pathway of histamine, which is the DAO enzyme. Sure enough, we treat that pathway and the bladder irritation gets better, so she's not getting up in the middle of the night and peeing 100 times, and even during the day. So that's just one simple example that how genetics can help you with so many symptoms.
Now, can I just expand on that?
Yeah.
Because we also had a patient we worked on together, that this lady was about, I don't know, 65, 70. Mm-hmm. And it was summer. She came in to see us, long sleeves, gloves, and I'm thinking, it's 95 degrees in Florida. You know, what's going on here? And she kind of lifts up the sleeve, and there's these just bits of skin and ribbons of blood. And I said, what's going on? She says, I'm wearing the gloves because I itch so bad that I'm just basically scratching myself to death and scarring from all the scratching, going on for about 5 years. So who have you seen? Well, I've seen, the people over at the university, the dermatology division. I've seen the best people here in Tampa Bay. Yep. Even went to a very well-known institution north of the Florida line. That's all I'm going to say. But as well, world-renowned for cases like this. And all they could offer her was steroids. Yep. And the steroids made her feel sick, and it didn't do really that much for her itching. So we used the 23andMe, yep, broke her down, and sure enough, the DAO enzyme. Yeah. And so, in fact, I actually called the institution north of the Florida line and talked to them. I said, did you guys ever think about going into genetics to get her better? Oh, no, we would never do that. That was the exact words to me. So we basically, I think it was $50, and 5 weeks later, you can fix that with the DAO enzyme.
And DAO enzyme.
And we gave that to her, and she comes back, short sleeves, no gloves, nothing. Completely different woman. And that's what makes, for us, medicine really exciting, because people that really been told, lady, just get used to it. Yep. We've used genetics to really get people better.
Yeah, and I do feel like we do that in the context of looking at the patient as a whole. We're not geneticists. We're not looking at you as one genetic mutation. We're looking at your hormone levels. We're looking at your protein intake. We're looking at your diet. Do you have enough omegas in your diet? And if you don't, we have to adjust that according to your genetics, what's right for you. That's why a lot of times also when people ask me, what should I eat? I would say I could give you a more accurate answer once I see your genetic profile, because what if you don't convert vitamin A correctly and I give you a diet that's low in vitamin A? that I could be hurting you. So I think we are, far enough, along in medicine, and we do have these tools available to us that we can use them. We just have to think and use biochemistry to be able to utilize that in a good way for your patients.
Now, do you want to talk about the person that the neurologist said he had ALS and we didn't agree with him?
Oh my God, no, I'd rather you talk about that because that was a special one.
So we see this gentleman
Yep.
in, I think it was September a couple years ago.
Right.
And he walks in and, just a lot of fatigue. He's seen a number of doctors also. And we did our little magic and all of that. And by December, he's in a wheelchair.
Right.
And we're trying everything. And he's going down the tubes on us. No energy, nothing. And we sent him to a neurologist. Neurologist calls us back. Well, two things, you guys. First of all, you've overdosed him on B12.
Right.
Because the lab said, the B12 is over their threshold, too high. That's really never bothered us because that lab test that LabCorp Quest does, it just tells you how much B12 is in the blood. And no one's died from taking in too much B12.
Yeah.
And the other thing is you need to get him in a nursing home because he has Lou Gehrig's disease.
Right. So
Whoa, that's a little surprising. So he came back to us, and we have a number of Lou Gehrig's patients in our practice, and he just did not seem to be
it didn't fit.
the criteria. So what we did is we gave him some methyl B12
Right.
just for energy,
Yeah.
and he had a seizure.
Right.
And you're thinking, oh boy, that was not
Yeah.
good. So we had him do the whole 23andMe. And sure enough, he had a genetic defect at the MTHFR. But he had another defect, a TCN2 defect.
Right.
So by what we had done by methylating him, he produced, I think it was too much serotonin
Yep.
and had a seizure. But when we got the additional information, TCN2, we realized that he has no vitamin B12 in his body, 0. Because he has a gene that B12 cannot cross the cell membrane to get into the cell where it needs to be. So he had a cell membrane problem, and so the only B12 he can use is one that I wasn't that familiar with
At
years
that time,
ago,
yep.
was adenosine hydroxy.
Yep.
So we gave him adenosine hydroxy B12, and basically $50, and 4 weeks later, he's out of the wheelchair, walking normally, completely different guy.
That was
He did
amazing.
not have Lou Gehrig's disease.
Right.
He would have spent the rest of his life in a nursing home for a disease he never had. He had no B12 in his body, and yet we would have only discovered it by looking at him genetically and being able to figure out what was going on.
There's no way. You're right. At that point, I was not really aware of adenosine B12 or hydroxy. It really, in medical school, you're really not taught the difference in it. You have to be researching these things, and as it comes out on the literature, you have to keep up with it. Otherwise, you don't know. You just think there's one type of B12. No. There's more of them, different types.
So I think what Alex and I are learning over the years in medicine as a practice is this, that you can, everyone, if someone comes in sick, we do know they have a problem.
Right.
And it's really how far down or how deep do you want to go down to really discover the answers.
Right.
And, most doctors aren't going to do this because, as one doctor said, okay, well, so can I just read something and I either give an antibiotic or I don't? I said, no, it's not that.
No.
You have to look at these pathways and figure out what you're going to do. And I will say this, it's hard,
Yep.
but you know what? It's better when you see patients say, John, I was doomed, and you and Alex have completely changed my life.
Yeah.
So I think this is more of an informational
Right.
podcast, but maybe talk to your doctor if you're not getting better. Maybe he needs to look at you genetically, break you down. We have found it's been very helpful in our practice, and hopefully this is information you can use.